Okay, continuing from where we stopped. Through the last session on basic programming, basic Python programming, we looked at the installation, we looked at the basic syntax, we looked at comments, we looked at variables, variable names, data types, and Python casting. Now I want to move on to the next part, which is talking about strings. I want us to explicitly discuss strings. So I'm going to make string to be like a topic on its own. So I have strings. So this is markdown. Let's run this way. So we go. So what are strings? How do we make use of them? And what are the rules in their applications? Like I mentioned to us, strings are just like the normal terms that we make use of in our day-to-day activities. In the same way, we are going to consider them along with arrays, because they are just like arrays on their own. So there is hardly a Python program without strings. Now the simplest string I can think of at this level should be maybe m equals my name is Boris. This is a string. In this situation, m is a string. So I'll put a comment here so that I can run this one. Good. So if I call m at any point in time, it gives me that. If I say print m, I get that. Okay. Now, the next step, which is something I need us to pay very close attention to. In computing, m as it is 0. The position of m is 0. Y is 1. There's a space between this, which is 2. This is 3. This is 4. M is 5. 6. In that order. The oldest time is 0. And it ends with the number of characters minus 1. So the last character is the number of characters minus 1. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The position of x will be 16 minus 1. That is 15. Okay, so if we decide to print, let's say we decide to pick m, m2, m3. I expect that to be n. That is 0, 1, the space is 2, 3. That is n. So in a similar vein, if I do print m, 3, it will give you the same thing. So you either use the print function or you take it straight. So basically that is how it works. Now, if we do as we did here, what we are trying to do is that we are looping through the whole statement and picking the alphabets one after the other. Now the next thing I want us to look at is the string length. Length of the string. If I say the length of m, that should be 16. That's the number of characters, including space, because Python sees space as a character. So we can as well say print length of m. It's the same thing. So it depends on whichever way we want to take it through. Now the next thing is slicing strings. How do we slice strings? How do we slice strings? In other words, we are taking a part of it out. That's it. So how do we do that? Now, if I say my name is Boris and I'm interested in from the beginning to a particular number. Let's say I'm interested in m, all the numbers from the first to the fifth one. I put a colon here. That means this means starting with the first number up to the fifth. So that should give me my space NA. Okay, and yeah, because I space in between. So in the similar vein, if we do M, 4. I'm saying go to that string of M. Go to the item, the character number 5. Print everything there up to the end of the string. So that should give me from A to the end. Okay. So if it is negative indexing, it's coming from negative indexes from right to left. How do we modify strings? That is turning a string to uppercase. That will be m dot upper. Oh, sorry, I left out something. M dot upper is a function. That is it. Turn the whole thing to uppercase. Now, in a similar vein, the lower is part of it too. Wow. That's it. So these are simple ways of taking care of them. Now, the next thing is to want to remove spaces. Remove spaces. So I do m dot strip. Takes out all the three spaces, the one before m and before and after s. Now I want to replace something. Let's say I want to replace B with P. So to replace B, upgrade with P. So we do M dot You do m dot replace. Dot replace. The former value is b. The new value is b. So all you need to do is to give them single quotes. Okay. Now the next step on strings has to do with concatenation. You want to combine two strings. You want to bring them together to form something. Let's say string concatenation. Now let's say we have m equals London. Equals bridge. I do London Bridge as a word. So k equals m plus, we can leave a space in between. You are concatenating the space also. If I do m plus n, it gives us, let's print it. Okay. You write them together without space in between. But if we want to keep space in between, we'll keep space such that m will be plus n. So if I call k now, that is it. So the next thing is formatting strings. How do we format strings? How do we format strings? Formatting today, no. Alex is equal to 34. And a text has it that his name is, I want to copy that word as usual. His name, I want to join in with Alex, is, I can skip space here so that I do my concatenation at this level, is Alex. Alex is 34. I want to make this a string so that I can combine them. Alright, we'll continue. Now, while bringing in the age, we can format it and tell the system how to display it by saying txt equals name is, now because we are going to format it, I keep a space here, here, here. Then I can do a print. Txt dot format Alex. Sorry, format text. Format Alex. That's it. So in other words, we are trying to write it in such a way that it's formatted from the way it was. We wrote it with 34 as a string. Now we have formatted it to 34 as a number. Now the next thing to do, yeah, basically I think we've covered quite a chunk there. Next, let's move to booleans. Talking about booleans. Booleans. We have booleans, we have operators. Booleans are just numbers like, we have discussed them earlier. That is variables with two possibilities. Yes, no, boy, girl, dark, fair, and things of that sort. Now let's move to operators. The way we have operators here, plus, minus, division, is exactly the way we have it in normal algebra. So there is no difference. It's the same way. Then we move to list. Yeah, we'll spend some time here because we need to have thorough understanding. It's not too far from the way strings are. Almost everything here we have discussed on strings, so this should be smoother. Talking about lists, what are lists? What do they do? Why do we need them? Of course, you can have list of anything, list of students, list of this, list of that, list of anything, so it can happen. Now, what we want to do now is we want to like consider list explicitly. So to do that, you first take a very simple exercise, a very simple example. Let's look at fruits. I'll call it my fruits. My fruits equals is a list of fruits, so I have to open a square bracket for them. That's the one big thing that differentiates lists. A square bracket, apple, orange, guava, mango, grape, okay. So we have that be a list of fruits. Now I can print it as it is by two ways. Can do my fruits thumbs up, or we do print fruits. And I mention for you, I still prefer to do it without using the print function. It's just me. Okay. So the way we explain it on string is the same way here. This fruit is 0 position. This is 1. This is 2. This is 3. This is 4. So that means if I have 1, 2, 3, 4, 5, the last one is the number of fruits minus 1. So the number of entries in a list minus 1 is the position of the last one. So let's note that place. So since I have 5 here, I can find out the length of this list. I'll say length. We did it also before on strings. Length of my fruits and 5 of them. Okay. So if we want to say, let's find out the data type of the list. Print type my fruits. Yeah, it's a list. It's a list. That's a list of fruits. It's a list. So you can pack as many things as possible in your list. It doesn't matter. You can have a list combining integers with characters and the like. It's fine, it's in order. Okay. Now the next thing is to talk about list constructor. When we talk of constructor, that is just like a small function that makes us to create a list, like as if we are creating a list from another list. That's a constructor. So let us understand some stuff about arrays. Point to notes about arrays. So this is going to be marked down. Now the first one is to state that dictionary is a collection which is ordered. Ordered means you can have ordered like 1, 2, 3 positions and not changeable. No duplicates. Collection ordered but changeable. You can change the position of any of the elements. Changeable. And it allows duplicates. Number 3, set. The collection is unordered, unchangeable. Allows duplicate members. It's unchangeable, but you can add some duplicates there. Then the next one is tuple. tuple. Tuple is a collection which is ordered and unchangeable. Sorry, set and tuple are not changeable. Unchangeable allows duplicates. So between sets and tuples, the difference is that you cannot have a duplicate member in a set, but you can have duplicate members in a tuple. So when you have something that's close to a set, or has some duplicate members, it is not a set, it is a tuple. Now, how do we add to a list? We have a list already, but we want to add to it. We want to add to it, that is, events are changing, and we just feel we should add to it. So, how do we add to a list? For example, I have a list of fruits, but I want to add to that list. I don't want it to be just that. What do we do to add to a list? Adding to a list. I have my fruit there. Now I want to add watermelon there. I want to add avocado to it. So how do we add? That is the next question. What do we do to add to it? How can we access those things? To access, we know that. How do we add to it? Now, for us to add to a list, we use the term append. So I'm going to do my fruits dot append. What am I adding to it? Avocado. Now, as I'm adding it, I'm not telling the system where to put it. What the system will do is that you take it to the back. So let's add this and see the result. Now, if I call my fruits now, I should have, yeah, you can see avocado at the back because I did not tell the system where to put it. So it will default it to the back. In a similar manner, if I'm inserting, if I'm taking away an object also, it's done in a similar way. But now I want to tell the system where to put it. So, instruct the system to place an object, an item, in a particular place. I have my fruits dot insert. I'm not going to use append. Append places it at the back, but I have to use insert this time around because I want to state the position. So when you're putting this, I want you to put it at number 2 position. That is, I have 0, 1, 2. So what I'm bringing in now, push this one to 3. So put it number 2, and what are you bringing in there? Pear. So if we write my fruits, it becomes apple, orange, pear, guava, meaning guava will have been moved to the next position. So let's run that. my fruits. That's it. Okay, the next one. Now we want to extend a list. What does it mean? What do we mean by saying extend? Extending a list is just like you combining two lists together. That is, you are extending one to the other. It's another way of like bringing them together. So, that is my fruits. Now, I want to have her fruits equals, let's do is fruit first. Is fruits equals, is fruits equals equals tangerine watermelon strawberry that is his fruit. So sorry. Now let's check his fruits. Now I want to use this to extend one to the other's territory. So I'm going to extend my fruit to his fruits. It's like combining them. So extending my fruits to his fruits. So that means we're going to write my fruits because I'm extending it. It dot extend to where is fruits. If I call my fruit again, I'm going to have something different, much more than what we had, my fruits. So it has combined everything. Now, I need you to note that when you combine or extend, whatever you are bringing in will be at the back. Where this other one stops, that is where that takes over. Right. So the next thing we want to look at is, yeah, we know how to access list already. That is, we know the one on port 0, 1, 2, 3, just like we did on string. So there is nothing serious there. Now, how do we remove from the list? I want to take out some. For example, I want to take out watermelon. So, to remove watermelon, from the list, all I need to do is to just use the remove statement. I'll do my fruits, just remove. Then I'll state my watermelon in the bracket. Yeah, so if I run this, watermelon. We have an error here saying list does remove X. X is not in list. No. No, we have it there already. Okay, let's try to remove something else. Let's try to remove orange. So, if I do my fruits again, orange is gone. Orange is gone. The watermelon was because I used capital W and I used small letter. So now I want to remove not by name. Now I want to use an index, the position or a name to remove it. So all I need to do is to do my fruits dot pop. What am I popping? I'm popping the last one. The last one is -1. I'm taking it out. Remove means I'm taking it out of it. So we have quite some functions like that, which I'm going to get used to as time goes on. What else do we want to do? So we have quite a lot of things to do with list. Can copy list. If you want to sort it now, it's straightforward. It's just to say sort. My fruits dot sort. That's it. So you want it in descending order, you can do sort. This is the default is ascending. So in descending order, you do my fruits dot sort also, and you tell the system reverse. So if I call my now, it should reverse. That's this in reverse order. Avocado, that was the last before, is not the first. Now the next thing I want to do on list is, okay, you can copy list if you care to. To copy is easy. You just call your name and do copy. I want to say fruit equals a copy of his fruits. So I will just do his fruits dot copy. I'm going to call the copy function. So I have that. So if I now call our fruits now, what I had as is fruits. Okay. So the way we treat this, we treat them all in similar ways. Talking about tuples and the rest, we treat them same way. Sets, they all have similar ways of doing the whole thing. So now I want to move to the next part now. I want to talk about branching. Python function. Talking about if else conditions. Python conditional statements. Conditional statements. So we're going to talk about if, else, do, while, and the like. So as soon as we are done with that, I think we are good with the basics that's of interest to us. So we'll quickly do that. Then we'll be good with that part. Then we can do some stuff on Python. We can do some stuff on how to handle files. Then some file handling, we'll do Python, Python pandas to an extent. Just take some pandas tutorial, just some stuff on panda. So which will be beneficial to us. So quickly let's look at if conditions. So we're going to talk about if, else, while loop, for loop, functions, then maybe array, classes, inheritance, then we close it. Okay. In Python, equal is written as n equals n. Not equal is written as m not equal n. Less than is the usual less than. Less than n. Greater than is similar vein. Greater than is similar way. Then less than or equal to then same way greater than or equal to. So I need to turn this to Markdown. Otherwise the whole thing will be in a mess if we run it now. So I run this. That's it. Okay. Now the next thing we want to do, which is the first part, we want to use the if statement. N equals 20. N equals 100. If m is greater than n, this should go with a colon. When you press the enter, there's an indent. Then the system should print, that means display. We are telling the system to display. Print not good at all. That is if m is greater than this. Now, if I run this, the system will look at it and take the appropriate position. Let's go. Why do you think it's not coming up with anything? Now watch. Can you see? There's an indent there. Now, do you know why it's not printing anything? Because m is no greater than 100. And I did not tell the system what to do if m is not greater than 100. So let's now add that. I'm going to come here and do else. Sorry, else, colon. Print nice one. So the answer I'm expecting here should be nice one. That's it. Now you can have nested if. That takes us to the next part called elif. This is using if else. That one is elif. So I'm going to use the same one to explain elif. You can see the book, it keeps going endlessly. You keep writing your code. Just one document. Everything is there. Okay. So here, elif. That is else if. Else if. Elif m is equal to 200. What do we want the system to do? What do we want the system to do? What do we want the system to do? Else if this. So we can say, nice one there. They will not come back again and do else. Can do this. No answer. Oh, elif is equal to, this should be, our equalities should be double. That's it, no answer. Okay, so we talked about elif, we talked about if, we talked about else. Now the next thing we want to talk about is, so we have two ifs here. If this, then the last one is always the one that carries else. the last option is always the one that carries else. Okay, so let's quickly look at the next one, which is while loop. While loop. While loop. I have I is equal to 1. And I'm telling the system that anytime I is less than, remember I is starting from 1. Anytime I is less than 10, print it. Just print I for me. Print. I expect the system to print 1, 2, 3, 4, 5 up to 9. That's it. Up to 9. In 9 places, like that. Endlessly. This one will go endlessly. 1. The reason why it's not doing it like 1 to 9, you will see now. If you run this, it keeps going endlessly. The reason is because after printing 1, we did not tell the system what to do next. So when you have printed 1, which is I here, you have to tell the system, go back again. That is I equals I plus 1. Go back again and print the next one. So if you print this now, it will give you something different. To give you something different. So it is either you write it this way or you say I plus equal to 1. So whichever way gives you the same result, in as much as I is less than 10. Okay. It's still running. That you can still start here. Yeah, because I did not terminate the other one. Now, when you run into this kind of scenario, you can terminate it, go to the top here, tell the system to interrupt it. Yeah, it's done. So I can run that one now. See, we have 1 to 9. Then we use break statement. I have my I from 1. While my I is less than 10, I'm going back to the same thing. While my I is less than 10, while my I is less than 10, I'm telling the system to print I. Now, when you are printing, if that I is equal to 5, just stop it. That is the word break. Stop. Go back again and pick another I. This is I. This is I. We have said I should stop at 5. That is the use of break statement. We use the word break. Okay. Now, the last part of conditional statements is a for loop. For loop. For loop. So we use for loop when we want to iterate over a list. Over a list, a tuple, a dictionary, we use for loop. So, I will go back to my fruits. Now I want to print everything one by one. Okay, it has even printed it, so I don't even need to use this. If I say look through the system, it's the same way. Let us do something. We want the system to stop running when it gets to Mango. When it gets to Mango, I'll say for k in my fruits. It's just an arbitrary term. In my fruits, print k. Print. Now, if k equal to, just like we did on the other side, is equal to Mango, break. Just stop. Break. If k is equal to Mango, okay, I left out colon here. What's again? Indent. Okay, my break should have an indent. Yeah. When you get to Mango, just break. Okay. So we've learned major part of the basics. Now we want to look at functions, Python functions. Python functions. I want to look at Python functions. So I'll turn this to Markdown. Python functions. So I'm going to flog this one explicitly also because we shall be making use of them from time to time. Okay. How do we define a function? We use the word if. My function. And I have a colon here. I'm done. So I can say this function is to print. Anytime anybody calls that function, it should print London is in the UK. So it will not give you anything unless you call the function. And how do we call the function? You just call it my function. Oh, sorry, it's in small letters. I use cap. Functions. My function. That's it. So if we now want to do, that's it. The moment you call it, it gives you whatever you have inside it. Now, let's go further. I want to define my function. My function. This time around, I want somebody to supply a first name. When that first name is supplied, the system should print f name that's on a concatenation now. Oladimeji. Or can you make the system to do anything? It's just trying out stuff. So if I call that function now and I say my function inside the bracket, and I put in email, enter email Oladimeji, because I've said that anytime anybody call this function, concatenate whatever must have been typed with Oladimeji. So we can make it better by placing a space here. Run this, yeah. Okay. So in a similar way, you can have your function taking two arguments. Instead of one argument, first name, you can take two. Can take two, can take three, depending on what you are looking at. So like I mentioned to us, we are not preparing this session for software developers, but a data analyst. We are doing it for data analysts. So we may not do some exercises that will take us into software development. Okay, so the next thing we want to do, this is just an overview. Yes, we want to deal with file handling. File handling. How do we handle files? File handling. That is, how do we bring in files into PowerPoint, into Python, and how do we take out of it? So file handling is key. Okay, so from there we have okay, file handling. How do we bring in Excel, CSV into the system? How do we take out of it? So that's what we want to do now. Yeah. So file handling. How do we open a file? How do we close it? How do we access the content of the file? What do we need to make that happen? Yeah, something like that. Okay. What are files? They are just a normal file like a Word, Excel, PowerPoint. So in Python, we have the opportunity of creating a file, of reading a file, updating a file, or deleting a file. So Python has, like every other languages, the following operations. Create, open, create, read, update, and delete. And delete. Now let's take them one after the other. We're going to look at the open file. What are the short acronyms used while opening files? At what point do we make use of each of them? Now let us note the following. Number one, R means read. 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 That is trying to read the file. A means append. W means write. Write. X means create. So these are short terms. Create. Append means you are adding to a file. Write means you are writing into a file. So they are almost the same thing. The big difference between write and append is that append creates the file does not exist. But write cannot create, it can write into a file that has been created and opened. So please let's note that. Write opens the file for writing. Append opens the files for appending. The two of them create the files if the file does not exist. But one writes, the other one append. Creates the file, and if the file exists, it returns error. Read picks the file, displays error if the file does not exist. Okay. Now, to open a file in Python, how do we open a file? We just call the open function open, then the file name. That's all. That's called open, then the file name. It's as simple as that. Open a file, we have k equals open. Go to the file, Maybe the file name is what now? I'm not sure I have the file in this folder. Yeah, the file can be anything. Just go there and pick it up. So the file does not exist. Let's see. K equals demo.txt. You see the message now. Because the file is not there. The file is not there, so it will not open it. But if there is a file of that nature, let me go to the folder and create a file in that environment. I want to create a txt file called demo. So I've created it. Now if I come back here and turn this to demo, actually, no, I'm not sure it's in the same folder. Oh, I put it in the wrong folder. Come on. It should be correct. I think it's in another folder. No, okay. This message shows that they are not in the same folder, so the file I must have created it wrongly somewhere else. So basically, it's just to call open and we are good to go. Okay, so where we read files. It's just the way we open, is the way we read. So I don't want us to waste much time on this area. It's something we shall be looking at explicitly also on what we call it, on pandas. So I want you to see it as part of what we are going to learn. So that closes this part of Python. Now the next part that we may want to do is the last part, which we are going to call is the last part that we are going to use for data. We want to use that part for data. So I'll have to take a break now and close this module so that the next time we are meeting for the next module, the last module, we shall look at pandas. Then from there we look at explicit database activities. So at this point we are done with the basics that we need to learn. Thank you.